Hello everyone. Today we will see how FortiSOAR can help investigating a malware attack. FortiSOAR is a SOAR product which is built with a multi-tier approach, in a sense where the variety of tiers that we have in a SOC environment would find each the appropriate tools and interfaces required for them to do their job. So if we take a tier 1 analyst, the very first thing the analyst would check typically is the dashboard. In the dashboard, we can find alert statistics per severity, per type. We can see the overall system health to make sure that the SOAR system is working in the optimum way. And also we have the list of the critical alerts which require our immediate attention. The interface is built with a drill down approach as well. So we can hover here over the critical approach, click here. The alert view is where the analysts, the tier 1 analysts, spend most of their time. It has a grid of the alerts with the different attributes of these alerts, and also a global filtering capability that you can see here with the filter criteria. So at the same time, each column has its own filtering field, and of course we can sort any of these displayed columns. We can also pick which columns to display in the main grid. In this case, we have few types: command and control, data leakage, reconnaissance. We can open each individual alert to get the details of that alert. So we have the description, we have the source, the destination, the reporting device, and also the user involved in this alert. So these attributes are also listed here. At this level, we have a further information tabs. So we have the indicators tab, where all the indicators related to this alert are listed after being evaluated, after their severity being evaluated with a cyber threat intelligence. We are using in FortiSOAR several ones, including FortiGuard, VirusTotal, Alien Vault, etc. So there are dozens of them that a user can leverage to get the reputation of the artifacts of each alert. Now, we also have a correlation tab where we have the different objects related to this alert. So we have the machine, so the asset with the IP address. There is an automated enrichment that happens at this level with the CMDB to get the department to which the asset belongs to. We have also a user involved in this alert. As you can see here, we have also the primary group of the user. This enrichment happens with the help of an Active Directory lookup. And the system also offers an automated mapped MITRE attack technique, which helps the analyst to understand better the attack, but also it proposes a mitigation to limit the impact of this particular attack. At the same time, we have here in the workspace a comment section which reports every single step that was taken within the investigation process, whether it was done via an automated playbook or via an analyst reviewing this particular alert. We have the recommendation tab. So this is the FortiSOAR record similarity engine. It's basically an engine which aggregates similar alerts based on configurable criteria. The configuration is right here, so you can see we can select here which criteria that we want to use for the aggregation, and of course what weight to attribute to each of these criteria. We can have specific filters to, for example, consider only criteria meeting a specific characteristic, and of course we can decide what automation playbook to run whenever for these aggregated alerts, or actually any other object for that matter, because the record similarity doesn't apply only to alerts, it applies to every other object in the FortiSOAR ecosystem. Here, the similarity record has detected 2 other alerts which are similar to ours. So this indicates that we have more than 1 infection. We'd rather have 3 of them. So we can select these alerts and then we escalate them using the escalation playbook into an incident. So this is a malware infection. We set the severity. It's obviously high since the CTI of the indicator is already critical. We can assign it to an individual user, and then we have to provide a reason why are we escalating as a tier 1. So this is a message to the tier 2 analyst to pick up the incident. So we can say, for example, critical indicator, escalate, and the alert, along with all the other similar alerts, will be escalated, as you can see it here in the comment section, to an incident, so a tier 2 analyst would pick it up. Now to the incident module, which is mainly meant for the tier 2 analysts and threat hunters. So we have our incident here with all the incident attributes, all the different alerts, the assets, users, the indicator. We also have a correlated MITRE technique ID remediations. So it would help the analyst to take the appropriate actions. We have a graphical correlation, which quickly gives an overview of the attack and its components. So we have three assets. Each asset has a user. We can see that they all, of course, belong to the same incident. We have vulnerability with a vulnerability ID. So this is the 2017-0144 double pulsar affecting the SMB protocol. This will be very useful a bit later in the investigation. An interesting thing here is the fact that the same alert here has a high severity, and here it has a critical severity. So this is due to the asset involved with this particular alert. Since the asset has a higher importance, automatically FortiSOAR increased the criticality of the alerts belonging to this particular asset. All right, we have, of course, the correlation, so all the objects related to the different assets in this incident, and of course we have here the reports. So there was an automated playbook running when the incident was created, and this playbook actually performed a threat hunting. So it performed it requested a report from the SIM solution to get the list of most used protocols amongst the infected machines, and also the list of dropped files amongst these infected machines. So remember, we had a vulnerability as indicated in the graphical correlation. We can clearly see that that vulnerability was used by the malware to spread laterally. As you can see here, SMB is the most used protocol between these infected machines. On the other hand, we have the list of dropped files. So we have a list of processes, we have the list of IPs or machines, and the list of dropped files. A quick look would quickly reveal an email client, which was used to download a PDF file. And then we have a Acrobat reader, so the PDF reader, dropping an executable, most likely by script. And this executable, we can see it afterwards in all the other machines, all the other infected machines. We have other dropped files, but they are obviously not relevant. This is Windows Defender, and this is some Microsoft task which is not relevant. But the relevant parts are definitely here because the report leverages the powerful correlation engine in the SIM to get the appropriate analytics which help us to identify and to understand what happens during this attack. All right, so by this time we have a clear view of actually what happened. So if we go back quickly to the graphical correlation, so we can see that we had a traffic to a C2 server, which indicates the existence of the malware. We see the malware moving laterally, all right? And we also know how the malware came into the environment. It was via this instruction PDF. So FortiSOAR has a powerful global search capability that we can see here in the interface. Let's look for this specific file. Have we seen it before? Does it exist somewhere in the system? So a quick search, as you can see, quickly reveals that the file already exists as an indicator. So we open the file. As you can see, the CTI doesn't yield any any severity or high severity for the file. The file is deemed to be to have no reputation, most likely because by the time the file was sent, it was a zero-day malware. So none of the CTIs nor the security infrastructure could detect it. We can see that this file is linked to this specific email. So we can open the email right from here. And as you can see, the email has a minimum criticality. It was processed in about, it was queued in about a minute and processed in 4 seconds only. It met the SLAs, but the thing is, this was deemed a false positive because the CTIs didn't have, by the time, any information related to this malware. So we can see that this is the email that was received, and this is the indicator file that was received via that particular email. So a spear phishing, this is an example of a successful spear phishing attack. All right, by now we know pretty much everything that happens. Started with an email dropped a file, the file spread laterally in the environment, and by this time it's extremely important to perform the mitigation. So we go back to our incident, and FortiSOAR has a mitigation playbook that we can run, which will limit the damage on the environment. So we only need to run the malware attack remediation. All right. The playbook, when it runs, it leaves a graphical log that we can see here. So as you can see, the playbook is at the approval stage. So we'll have to give the approval for the actions to be taken. So here's the approval: disable users on Active Directory, so it will not be used by the malware, and also quarantine the infected machines, so these machines will not spread the malware further in the environment. All right, so we can, for example, just leave a comment saying, for example, that we are approving the remediation, and we approve this step. We then go back to our playbook, and we can see that the playbook continued the execution. It went to FortiGate. These 3 IPs, which are the asset IPs, are being blocked, and the usernames are blocked as well, or disabled at the Active Directory level. We can double check as well here on FortiGate, so we can see the quarantined IPs, and it should be, our IPs should be amongst them. There we are. So we have these 3 IPs that were quarantined as a remediation to this specific attack. And by this, we get to the end of this demo. Hope it was useful, and see you next time. Bye.